Adrenaline, the Bazooka Prophet. And I'm so pleased to have you guys once again. Thank you guys for those of you who have subscribed to my YouTube channel. And for those of you who are new to this my channel, please do well to subscribe to get more academic content. And in this video, we will be talking deep into a very major aspect of chemistry, which is the calculations involved in chemistry that has been a problem to many students in undergraduates, precisely year one students preparing for examination. Now, in this video, I'm taking my time to give you step-by-step approach on top 20 questions or top 20 examination questions that are very, very important before you go into that hall. So let us begin. Now, the first question is solution. Let us do it together. The first one, the question says, how many moles of hydrogen gas are in 27 grams of hydrogen? Very, very simple. I've often tell you guys that whenever you are asked a question, do well to bring out what you are giving. Do not waste time. Now, how many moles? It means I am looking for the number of moles. And that for hydrogen gas, you have the mass given to us here to be 27 grams. Now, what connects number of moles and mass is the molar mass. So remember that for hydrogen gas, it is H2. So the molar mass of hydrogen gas, we were given our relative atomic mass of hydrogen to be what? 1.008, which is 1.008 multiplied by 2. I should be having it to be, okay, to be as 2.016 gram per mole. Do not waste that for those of us that are doing objective questions. Remember that number of moles is equal to mass over the molar mass. Take note. There are some questions whereby you'll be giving the number of moles, you'll be giving the mass, you'll be asked to calculate for the molar mass. Just know that this is the bedrock. That number of moles is equal to mass in gram over molar mass in gram per mole. Now, the mass here given to me, 27 divided by the molar mass is 2.016. And when we divide, we'll be having our final answer to be 13.39 mole. The unit of number of moles is in mole. Very, very simple. See the procedure. Now, this number one question is done. So we'll move straight down to number two. As I often tell you guys, calculation in chemistry are not difficult at all. So we'll be taking our time to take top 20, and I'm so sure they will be relevant to you in your examinations. So, question number two. We move to question number two. So, the question says, calculate the percent composition of nitrogen in magnesium nitrate. So what do? Very simple. This one involves what? Percentage by mass or percentage composition of elemental substances. And now we're looking for what? Nitrogen. Don't forget that percentage of nitrogen, which is an element inside the compound, is equal to the molar mass of nitrogen. Remember that the number of atoms of nitrogen here is 2. So we will say that molar mass of the 2 nitrogen here over the molar mass of magnesium nitrate. Now, what do we do first of all? The first step is to look at the shortcut here. Be able to calculate for the molar mass of this compound here, which is magnesium here is 24, which is 24 plus nitrogen here is, which is 14. Remember, we're giving it here, that's bracket 14 times 2 plus oxygen, which is 16 times the number of atoms of oxygen here is 6. How? 2, these 2 multiply everything in this bracket, which is 2 times 3 is 6, which is the parenthesis here. Will that become 6? So together here become 24 plus 28 plus 96. So let's not waste time. 24 plus 28 plus 96. 148 gram per mole. Some persons or some tests will tell you percentage of an element is equal to the mass of the thought element, of the element being thoughted after, over the molar mass of the compound. Now, permit me to rub off number 1 here so I can have enough space to be able to address the number 2 question properly. Now, what do I do? Please do not waste time. Percentage of nitrogen is equal, just come here. But the mass of nitrogen here is 28. Because already you already multiplied by 2 here, which is 2 times 14. Here is 28 over the molar mass of the compound is 148 multiplied by 100 over 1. Altogether, you'll be having it to be, okay, let's go, that's 28 answer times 100. And the final answer is 18.91. Okay, 18.92%. That is the final answer. You begin to see that calculations in chemistry for undergraduates are not difficult at all. They are simple. Take it from me. You can see a lot of students do have issues with them, but they are not. They are top examination questions. As if as they are, some students or a lot of students might have issues with them. So let us move to the last question for this episode 1 under top 20 calculation. Now, in the next question, is follow. You can use it to solve any other question that are related. Now, the next question, which is very, very important, very simple. The question read. The question says, determine the percent by mass of potassium chloride in a solution prepared by dissolving 1.18 gram of KCl in 86.3 gram of water. Meaning, your interest here is the percent by mass or mass percent. So, mass percent is equal to the mass of the KCl you are asked to look for, which is this one, over the total mass, which is the mass of the solute over the mass of the solution, consisting of the solute, which is the KCl, and water, which is what, and the solvent, which is what, water. So what do? We come here. The total mass here is equal to the mass of KCl is 1.18. The mass of the solvent, which is the water here, is 86.3. Add them both, which is 1.18 plus 86.3. Okay, all right. It is 87.48. Are you with me now? So we move. Now, the mass percent of KCl is now equal to the mass of KCl, which will have it to be 1.18 over the total mass of the solution, which is 87.48 times. Remember, it's percent. So what do? We come here to say 1.18 over times 100 over 1. And the final answer is equal to 1.3488, which is 1.35%. That is the final answer. And on that very note, we come to the conclusion of the episode 1 of top 20 relevant questions you can see. With this pattern, other questions can be solved. Just know the steps I used there. For now, I remember humble self, Adrenaline, the Bazooka Prophet. God bless you.